Okay, so these notes are on transformations and characteristics of quadratic functions, and so these notes are going to be just quicker than the absolute value notes. At this point, all the words are going to be more familiar to you. It's going to be similar to what we did last time, but just a little bit different because we're talking about quadratic functions this time. So we're going to go ahead and write down, you can see for our transformed functions, we still have a, we still have h, we still have k. Each of those letters still means the same thing that it did before. So if a is less than 0, if you don't want to write it that way, you can say if a is negative. If a is less than 0, then the graph has been reflected over x, or reflected over the x-axis. So that's the same as it was with absolute value graphs. If the absolute value of a is greater than 1, then you have a vertical stretch. If the absolute value of a is less than 1, then you have a vertical compression. Right? For the h value, this is going to shift the graph left and right. So if we have, I don't remember how I wrote this last time, so I'm gonna just write it like this time. I'm pretty sure I did not write it this way last time, but maybe this will make more sense. So if you have x plus a number, it moves it to the left. If you have x minus a number, it moves it to the right. It's going to be squared. And then on the end, if we have plus a number on the end, we're going to be moving up. If we have minus a number on the end, we're going to be moving down. So just like I said before with absolute value, I'm sorry if you can hear that. It sounds really loud to me. It might not to you. It's the rain. There's rain on the roof right now. So inside the parentheses, the number does the opposite of what you would think. So if it's a positive number, it moves to the left. If it's a negative number, it moves to the right. On the outside, it does exactly what you would think. A positive number moves it up. A negative number moves it down. Negative in the front only reflects over the x-axis. It does not tell you about a compression. It's the size of the number that tells you about a stretch or a compression. So these numbers are like decimals that are smaller than 1 or fractions that are smaller than 1. A stretch would be like a whole number, or a decimal or a fraction where the size is bigger than 1. It doesn't matter what the sign is though, because the sign of the number only tells you if it's going up or if it's going down. All right, so over here, let's go ahead and graph it. The parent function is considered to be the function with no transformations happening. And so we have x squared, so I'm going to plug in the -2. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1, and 2 squared is 4. So pretty similar to the square root graph, but it's going to look a little bit different because it's not it's not V-shaped, it's U-shaped this time. So we got 0, 0, -1, +1, +1, +1, -2, +4, +2, +4. If we were to do -3, that would be +9. +3 is +9. So we don't typically go up to 3, but we could for this, for the parent graph at least, so we can see it. So you're going to be really careful to draw this. It is U-shaped, not V-shaped. And there we go. So we've got 2 examples here. We're only going to do the first one on the video. We're going to leave the second one for in class. So it says find the transformations and the vertex and graph the function. So first we have a vertical stretch of 2. It is shifting to the right 2 and up 3. The vertex is +2, +3. I forgot to write that over here, but the vertex, just like it was with absolute value, is h, k. So that's the same as what we learned before. So I'm going to go ahead and write these points from the parent function. So I'm going to take the points and I'm going to do each transformation on them, and then I will know how to graph this. So stretch it by 2 means I'm going to take the y coordinate and multiply it by 2. So -2, 8, -1, 2, 0, 0, 1, 2, 2, 8. And then I'm going to take it and shift it to the right 2 and up 3. So right 2, right 2, right 2, right 2, right 2, and then up 3. So that's off the graph. Off the graph. The ones that are off the graph are just barely off the graph though, so I think we can still graph them. And I'm going to make sure to make it U-shaped. So there's our parabola. Now students always ask me, well, now we have 2 sets of points that we've done transformations on. We have absolute value, we have quadratic. Do we have to memorize those? Well, yes and no. You can memorize them if you want, but if you ever want to get the points, you just have to know what the parent function is, and you can plug in the x coordinates to get the y coordinates. So you don't really have to memorize them, you just have to know what the parent function is. So if it's a parabola, y equals x squared, then just plug in -2, -1, 0, 1, and 2, and there's your points. And then you can just do the transformations. Okay, go ahead and turn to the next page. We're going to do some of these in class. So vertex, domain range, increasing, decreasing. What I want to do actually is practice some of this calculator stuff. So the maximum and minimum, I want to write down in our notes how to do this. So the maximum and minimum, we already know what this point is, but we're going to do it on our calculator as well, because it's a good time to start learning how to do some of these problems with a calculator. So if we look at this, we already know from previous lessons how to find the maximum, how to find the minimum. We know from the absolute value graph that it's going to be the vertex, right? So I can see from this that my vertex is this point. And from the equation, I can see that that's going to be -5, +10. So my vertex is -5, +10. Based off the picture, I can see that that's a maximum. -5, +10. And so that for minimum, I'm going to say none. So that's pretty easy. I can see that already. Now I'm going to show you guys actually how to do that on a calculator, and I want everyone at home who has a calculator to do this with me, because sometimes the equation is not written in such a way where you can get that maximum point easily. So based off the image of the graph, we can kind of tell it's a maximum, not a minimum. So I'm going to go ahead and just start typing this equation. X plus 5 squared plus 10. And then the menu of options for different characteristics that you want to find from your graph, you can get to that menu by doing second trace. And you can see in blue that's calculating. We're calculating different things about the graph. So minimum is one thing you can find, maximum is another thing you can find. And the maximum is what we're looking for, so number 4. So I can see the maximum is somewhere in between here. I know my maximum is over on this side of the graph. It's somewhere between -10 and 0. So for the left bound, the left side, I'm going to say, okay, calculator, I want you to look between, and I'm just going to start typing in -10. I want my graph to look between -10 and 0. So I'm going to start typing -10. Press enter. Now it wants right bound, so 0. 0 is the right bound. I said that my max was somewhere between -10 and 0. Press enter. The guess, it's guessing 0, that's a silly guess. So I'm going to ignore that, press enter one more time. And my calculator finds it for me. Now, my calculator sometimes has a hard time with decimals, especially when I've made my guesses pretty far apart. And since I guessed between -10 and 0, those were kind of far apart. So my calculator is struggling to say -5, but it's there, -510. It found the maximum for me. So I could find it on the screen, but my calculator found it as well, -510. So that is the way that your calculator can find a maximum for you. This problem was easy, it was already there, but our calculator is capable of doing it too. All right, turn to the next page. We're going to do the same sort of thing, but we're going to find the X-intercept and Y-intercept using a calculator. So let's go here. We've got another equation, so I'm going to go ahead and clear this out. So I've got square root 2, I'm going to type that in, square root 2, parenthesis, x minus 1 squared minus 8. Okay, x minus 1 squared minus 8. I'm going to go ahead and graph it. All right, now I can see my x-intercept right here. I can see it's between -2 and 1. So I want to find that x-intercept between -2 and 1. Now over here, if I do second trace, there's nothing on here that says x-intercept. So what we're looking for here is called the 0 of the graph because it is where y equals 0, and y is another word for, or another letter for, the function. Okay, so x-intercept is called the 0 of the graph. Okay, we're going to do left bound, right bound again. So the left side is -2, the right side is -1, left bound, right bound. So I can see that the x-intercept is between -2 and -1. So for left bound, I'm going to do -2. For right bound, I'm going to do -1. There's my x-intercept. So my x-intercept, I'm going to do 3 decimal points, -1.378, comma 0. Okay. My other x-intercept, 1, 2, 3, 4, is between 3 and 4. I just counted it. 1, 2, 3, 4. I can see it's between 3 and 4. So I'm going to do second trace, the 0 of the graph again, because I'm looking for an x-intercept. My left bound is 3. My right bound is 4. 3.378. Okay, 3.378. All right, so those are the zeros of the graph. So the way that we did this is we did second trace number 2. That's how we did this one. Okay, now for the y-intercept, we're going to do second trace, and for this one, we're going to use number 1, which allows you to plug in any x value that you want, and we know that for the y-intercept, you have an x value of 0. So there is the y-intercept there. So our y-intercept is 0, -6.586. So this one, our instructions are second trace number 1, and we're plugging in x equals 0. You can plug in any x value that we want. We wanted 0. All right, I'm going to flip back to the previous page. We didn't put instructions on these. We can go ahead and do that. So for maximum, second trace, maximum is second trace number 4. Minimum, if we had it, would be second trace number 3. Right? Now, of course, we'll do more practice with this. I just wanted it to be in the video so that if you ever need to go back and watch it, you can. Now, don't worry about doing anything else in the notes. We will fill those out in class tomorrow.